Let us try this problem called absolute difference divisible by k. Let's have a read. Given an array of integers n and an integer, given an array of integers of size n and an integer k, find all the pairs in the array whose absolute difference is divisible by k. Okay, this is an example 3, 7, 11. K equals to 4. And so what can we do? We see these three different pairs, 11 and 3. Subtract, we get 8. It's divisible by 4. 11 minus 7 is 4, which is divisible by 4. 7 minus 3 is 4, which is divisible by 4. Another example, 1, 2, 3, 4, k equals to 2. We got these pairs. So one of the things that we could do, obviously the brute force approach would be, we have to find the number of pairs. So let's find out all the pairs. Right? Let's look at each and every pair. That would be n square. And for each pair, we can quickly subtract them and check whether or not they are divisible by k. So we could solve this problem in O of n square time complexity easily. But in this side, it actually mentions the expected time and space complexity, which is quite nice. So, but that doesn't force us to think, but okay. But clearly, the expected time complexity is n plus k. So we're not allowed to use quadratic time complexity. So we have to think of something better. Uh, Let us try something better here. So essentially what we're saying is what we are interested in is we are given different numbers and let's say x and y, and when we subtract them we want it to be divisible by k. So some m, it should be like this, right? And obviously any number, so both x and y, I could represent x as some multiple of k plus some, I don't know, uh, let's call it c1, where C1 is less than or equals to, could be multiple also, right? So it lies from 0 to k minus 1. And similarly, y could also be represented as maybe some b times k plus c2. And again, c2 is basically the remainder that you get when you divide y by k. So again, this. So now if you subtract x and y, you get a minus b times k plus c1 minus c2. And if you want this to be a multiple of k, what would you want? Well, you would want this c1 minus c2 to be equal to 0. What that would mean is c1 equals to c2. What that means is, well, x percentile k equals to y percentile k, right? So essentially what that means is, let's go through each and every number. Let's find out what is the remainder that we get. And all the guys which have the same remainder, you can make pairs from them. So let's say k equals to 5. So from 0 to 4, so 0, 1, 2, 3, 4, this is the remainder. And this is the count. How many numbers have the same remainder? And let's say, so in this case, so let's take in the first example. The first example is 3, 7, and 11. Okay, so let's look at the first example only. So the first example is 3, 7, 11. And k equals to 4. So well, if k equals to 4, that means what are the different remainders that you can get? Well, 0, 1, 2, and 3, right? And let's count for each and every guy. So for 3, the remainder is obviously 3. For 7, what's the remainder? So for 7 also, the remainder is 3, right? When you divide it by 4. For 11, well, 4 times 2, 8, and the remainder is again 3. So for all 3, 7, and 11, the remainder is actually 3. And for everything else, the remainder is 0. And for 3, the remainder is 3. So when the remainder is 3, for 3 of them, that means you can pick any of the 2 from them, right? You could do nc2, which is essentially n times n minus 1 by 2. So we find out the count of numbers with the same remainder, and for every remainder, whatever is the count, we'll do this approach, get the number of pairs from that remainder, and solve the problem like that. Let's look at the second example to confirm. So the second example is, so we have, oops, So the second example that we are given is 1, 2, 3, and 4, and k equals to 2. Okay, so if k equals to 2, that means the remainders can be either 0 or 1. And let's see what happens. So for 1, the remainder is 1. For 2, well, remainder is 0. For 3, remainder is 1. And for 4, the remainder is 0. So based on remainder 0, there are two numbers. So 2C2. For remainder 1, there are two numbers. Again, 2C2. And if you add both of them, you get 1 plus 1, 2. And that's the answer. All right, so let's build the logic based on this approach. To save the count of remainders, we can use a hash map, or we can also use just an array, right? So let's just use an array. We'll call it remainder count, or count by remainder, right? So go count by remainder, and you go, its size would be 0 to k maximum, so size would be k. Let's go through each and every number now. So for each num in the array, I'm going to find the remainder. So remainder equals to, well, num percentile k, and I'm going to do count by remainder of remainder plus plus. And we've got the count for each and every remainder. Now we go through this. So for int I, for each remainder in, not it, for each count rather, right? So for each count in this count by remainder, uh, let's do total count. So total pairs equals to 0, and this is what we will return. So so pair would be what? NC2, right? So count could also be 0, but okay. Uh, when you multiply something by 0, it should become 0. So count times count minus 1 by 2. So these are the pairs that you get from this remainder, and you add these pairs to the total pairs. So total pairs plus equals to pairs. All right, so now what's the time complexity here? Obviously, we go through the nums array n, then we go through the this count array, which size is k. So the time complexity is n plus k, and the space complexity is k, which is what the requirement is. Now let's run and fix any issues. Seems like it works. Let's submit and see if all the test cases pass or not. And they do pass. So that was a nice problem, uh, quite basic, but still test the fundamentals. All right.